So over in Maya, just going to hide my spheres, and I'm just going to create a tube here. So let's have a look at a typical workflow in Maya. I'm going to basically just scale this up. So let me have a look at the network here. I'm going to go to the original polycylinder here, and let's change the height here to something like 6 units. And I'm going to change the subdivision axis to 8, and the subdivision height to something like 10. So we've got a little cylinder there. Using history, I can change the subdivisions after the event. Now, to get this to sit on the grid, the typical workflow in Maya would be to snap the pivot here down to the base, and then snap the whole object up to the grid. So we know that we're sitting perfectly on the floor there. Now, let's look at how we would maybe handle the similar kind of thing in Houdini. So in Houdini, let me just hide this sphere. I'm just going to create again a tube, just to show it's very similar to Maya. And on the tube object, we'll add some end caps. And again, we'll give this a height of 6. Make it the same proportion, radius scale of 1. And this time, well, I could do things like Maya. I could actually snap this up using grid snapping and moving, but that's not the kind of the way that we do things in Houdini. What I'm actually going to do is I'm going to add another node called a transform node. And the transform node will let me move this object around independently of the transform node above. The idea is that, as I alluded to before, that we create our own shape node in here. So we could build a whole system. You know, this transform node could contain a whole city with lots of objects all moved around in different places, with all of their own transforms, which gives us quite a bit of power. Now, with the transform node, in fact, let me just give this the right number of divisions there. We wanted, what, 10 there and 8 that way. So in the what we would normally do is we'd build in some behavior into Houdini to give us that procedural flexibility later on. So one trick I might do in the transform node here is tell it to lift itself up here to the bottom of the bounding box. So if I type in $$y_min, this will return the -y of the bounding box of the object, and then I'm going to negate that with the minus sign and move it back up by that amount. And as you can see, that sets the negative bounding box to the grid. Now, the reason we do a little bit of this in Houdini is the fact that I can now change the height of my tube, and you'll see he'll always stay on the floor. If I go back to Maya and I try and change the height of my tube, he doesn't stay on the floor. I'm going to have to snap the pivot and reposition him by hand. Yes, we can in Maya write some scripts similar to how I just did in Houdini to automate this process, but that's kind of where it stops. I mean, we could do that, it's very easily done, but let's make it slightly more complicated. Actually, I will just quickly demonstrate that. So in the translate y here, we could just write a quick expression. So I'm just going to say that the translate y here would be equal to, so we want to get the attribute of our cylinder. So let me just type this correctly. Cylinder shape 1, because the shape node holds the bounding box information. And then we can ask for, let me spell that correctly. We could ask for the bounding box max y, like so. Let's hit create, see if that works. There we go. I don't need to multiply by half because I've already moved the pivot to the center. So look, if I now change the height, yes, it doesn't look like it's updated, but if I just switch the timeline here, you'll see it then does in fact update. So let's put that back to 6, switch the timeline. The timeline forces the DAG graph to update, and then we see the result. So I've put a kind of Houdini-like behavior in there, but as you see, Maya's not really kind of set up for that. But as we make it slightly more complicated, this gets slightly more difficult. Let's look at another case. Say, for example, I want to select these faces, the second row down of faces, and I want to extrude them outwards. like this. Let's turn off the keep faces together and let's add some divisions. That's fine and dandy. But the problem comes now is like we've done this and the director goes, actually I want to change the topology. Can we have some more divisions up and down, or can we change the subdivision axis? And as we know in Maya, that just never worked. That's just, you know, we'd have to delete the node, delete the extrude node, remake the selection and start again. It's not very flexible. So let's look at how you might handle the same kind of approach in Houdini. So in Houdini again, so here again I'd like to select these guys. So we wouldn't select this manually in Houdini, but you could, but generally you tend not to. We would use a group. In this case I'm going to use a group by range node. Groups in Houdini are similar to sort of selection sets in Maya, except they're a lot more flexible. You can think of these more like masks, so we can get nodes to operate only on particular subsets of the geometry. Think of it as a geometry mask more than sort of a set. And these are quite dynamic, which is really good. Let's change this name of this group to selection. And we're going to select these faces from the start to end. And what that means is I'm going to pick face 0 and end at face 0. If I turn on the face numbers, we can see that the top one's face 0, the bottom one's face 1, and then we start counting 2, 3, 4 round at the sides here. So if I wanted to select face 2, I'd start at 2 and end at 2, and we select face 2. What I actually want to do is start at, well, the number of columns plus the top and bottom, because you see it counts the top and bottom first. If I go to the number of columns here, that's set to 8. So in Houdini, what I could do is actually copy this parameter, and I can paste this relative reference here. So this is now linked to the columns. And you can see that the number I'm returning is the same 8. Let's also end this at 8 so we can see where we are. There we go. Now I don't want to start at 8. What I actually wanted to do was start one column down. So this is in fact times 2. Let's make this very high actually so we can see where we're selecting. Sorry, I like that's plus 2 because we want the number of columns plus 2. So this is not selecting the first 10 plus the 0 and 1, and now we're starting to select the second row. Now I don't want to select all 100. What I really want to do is to select enough for the second row. So again, we'll just paste in the relative reference there, which gives us the let's get rid of that 10, gives us the number of columns. But again, this will be times 2 because we've got twice the number of rows here. And we just need to add the extra 1 on the end there. So this gives us the entire second row. Now the reason I've done that and built in these behaviors is they're linked to the number of columns. So if I do happen to change the topology now, you'll see I'm always linked to the second row. And we've built in that nice bit of flexibility. Now what I can do is now I can do my poly extrude. If you see, if I do everything, that does the whole thing, but since we're using the groups, we can use that as like a mask filter. So I'm saying just extrude the selection here. I can tell those to be not connected elements. There we go, and we can give it the 3 divisions that we saw in the last bit. So again, something you can't do in Maya is sort of build in this behavior using groups to allow this flexibility of changing the topology after the event. And still keeping the things that you want. Now let's just pop back to Maya and add some more bits to this, and then we'll compare the networks. So I'm just going to add a non-linear twist deformer, and let's just adjust the end angle to give our thing a bit of a twist. I'm going to add a second deformer as well. Let's add a bend deformer too, just give it a bit of a bend. So now we have a bit of a bend and a twist. Let's recreate the same thing in Houdini quickly. So again, let's create a twist deformer. As you'll see, they're very similar, being 3D softwares. 3D softwares do very similar stuff. Actually, let's set the axis correct up the y-axis here first, and just set the box. capture region, and we'll just twist that in, and then we'll do a bend after that again. So let's make sure we're bending up the y-axis. Let's set the capture region, and we'll just bend that over again. So very similar again to Maya. Just going to pop a null at the end of the network here, just to give me a little bit of flexibility. So looking inside Houdini here, in fact, let me make this panel big and just tap P to see the parameter pane. So if we look at the network in Houdini, it's fairly nice and succinct here. We have our tube, which we transformed procedurally, which meant we could then change the height of the tube. We then selected a group with some connections to how many columns there are in the tube, so that even if we change the topology, we're still always selecting the second row. We then extruded that group. We've then twisted it, bent it, and then we're seeing the result. Now let's go to Maya and have a look at the node network that Maya has created for the same thing here. So if I select my object and just look at the network, the node view here, we can see this is certainly not as succinct as Houdini. We can see the same kind of nodes going on there. We have our twist node and our bend node, and we have a whole bunch of other nodes in here. These are other Maya support nodes, and you can see it's certainly not in a linear straight line like Houdini. It cycles everywhere. This is called a DAG, or directed acyclic graph, and you can see things loop around. It's not really designed for you to go back in here and sort of manipulate stuff. If I want to go and edit what's happened to this guy using sort of the notion of Maya's history, for that we would want to go to the channel box. It's in the channel box here you can see the inputs, or your history, and it's here that you can easily select the nodes that are in the network here, rather than trying to worry about the network. So look, I can go back to the original cylinder, and I can change the height and the axis, but obviously not the subdivisions, because we know that issue with Maya. But look, we can also find the extrude here, and I can go back and adjust the extrude, or I can find the bend node and readjust the curvature, and then I can find the twist node here. Where is it? Twist node. And we can adjust that. So this is kind of like your history stack, or your operate your node kind of stack. So this is how you'd go back through sort of your node network and edit it in a kind of Houdini-like way. And you'll see it's a bit of a mess and not too flexible. Yep, there's a couple of things in the outliner here. These aren't really access to the nodes. The only reason we see these handles is because we can transform them. If there wasn't transforms associated with these nodes, we wouldn't see anything in the outliner. So again, just back to Houdini to compare. So very easy in Houdini just to select any of these nodes now and re-edit them. Oh, in the parameter pane, you just want to select them, and then you can just grab their sliders. Now the other advantage of Houdini and working procedurally here is the idea of a procedural software is each node is a procedure. This just defines a tube, this just happens to transform whatever's plugged in, this just happens to group whatever's plugged in, this will extrude whatever you tell it to, this will twist whatever's plugged in, etc., etc. And it literally does what it says on the tin. There are no looping or cyclic behaviors here. And the advantage of having such a clean network, or this list of procedures, is the fact that we can change the order. So look, for example, I could turn the twist off, or turn the bend off, and turn the twist back on, or turn the bend back on. Or we could switch their orders around. So look, instead of doing the twist first, we could do the twist after the bend. Get a much more interesting deform. Or instead of getting the extrude getting twisted and bent, we could actually detach the twist and have the extrude, and have that extrude at the very end here, and get a slightly different result. So it's very flexible that we can change what's going on. And once we've built some behaviors in there, we can, as you saw, adjust the height and adjust the divisions, and we can still keep the things that we want. Yes, we can do similar things in Maya. In Maya, we can manipulate these inputs to some degree by right-clicking on the object, going to inputs, and bringing up all inputs. So similar to Maya, again we can turn off our nodes. There's turning off the bend, and here's turning off the twist, and here's turning off the extrude, which I can't actually do. And we can change the order of these a little bit with a middle drag. Well, in fact, you can only change the order of the deformers. Notice the bend and twist, but I can't swap them with the extrude here. What I'd have to do is either undo or delete the extrude and remake it afterwards. That kind of thing in Maya. So again, we're not very flexible here because it's not really a true procedural system here. It is a cyclic graph. And as a result, the network is obviously not as clean and not as easy to understand. Let's now look at how Maya and Houdini control geometry and attributes and the differences in terminology.